Hello, good morning, dear students. Welcome to Interactive Virtual Class Nagaland once again. I hope all of you are doing well. As students, so in class 9, if you can remember, we have discussed about various elements, right? The different types of elements present in nature, or there are different types of elements that we can find in nature. Yes, and out of these elements, we can broadly classify them into metals and non-metals. Yes, students, do you remember? So how do we classify the elements into metals and non-metals? We will learn that in today's class. Okay, but before that, let us look into some of the uses of metals and non-metals. So here we see that construction is going on, right? So now in construction for tall buildings, it is difficult for us to carry things from this ground to the top, right? It is difficult for us to carry all the construction material from here to the top. So we use some type of structures like this. So what are these structures called? Yes, students, these are the structures which help us to carry, okay, the heavy load from the ground to the construction site. Yes, students, so these are the crane, and these crane are made of metals, correct? Yes, students, we have another example here. We see a person driving a car. So what is the car made up of? Okay, or what are these wires made up of? Yes, students, so here the car parts, okay, the car parts and the electrical wires are also made up of metals. Yes, the next we have is a bell. Okay, we see bells in church, in temples, right, to ring, right? It produces a ringing sound. Yes, so we use this bell in churches also. So what are these bells made up of? They are made of metals. Yes, now let us see here. Here we see a woman, a lady, covering the food on a plate using a foil, aluminum foil. So what is this aluminum foil made of? It is made up of aluminum. So aluminum is also a metal. We also have aluminum utensils. Yes. So this is also another uses of metals. Okay. Now let us see here. We see here a person relaxing, meditating, right? So we breathe in and we breathe out. We breathe in oxygen and we breathe out carbon dioxide. Yes. So what are these oxygen and carbon dioxide? Okay. Are they metals or non-metals? Yes, students. We will see that. Okay. Another example we have here is, now we see a mother cooking in the kitchen using gas. We also have utensils with handle which are made of rubber. Yes. So what are these material made up of? Okay, they are made up of non-metals. Okay. Another example can be this one. Here we see a boy drawing on a paper using pencil. Okay. So what is this pencil lead made of? Okay, this pencil lead, what is this pencil lead made of? Is it metals or non-metals? Yes, students, it is non-metal. The pencil is made of non-metals. So when we look at all these examples, okay, here we see a person entering the room, then he switch on the light. Yes. So what is this socket made up of? Okay, what is this electrical socket made up of? Okay, so these are the various examples. We have seen the different uses of metals and non-metals in our day-to-day lives. Yes, in some examples we see the uses of metals, in some examples we see the uses of non-metals. So these are some of the uses of metals and non-metals in our day-to-day lives. Okay, so we will begin with the chapter metals and non-metals in today's class. Okay, so we have seen the different uses of metals and non-metals. So how do we classify them? Okay, with what property, based on what property, how do we classify the elements into metals and non-metals? Or how are the properties of metals and non-metals related to their uses? Okay, we have seen some uses of metals and non-metals, correct? For taking the example of grain. Okay, what if we use non-metal material for making grain? Okay, what will happen? Okay, so metals have different uses, non-metals have different uses. It is because of the difference in their properties. But how do we classify them? Okay, let us see in today's class. Okay, so here this is the periodic table, the different elements. Okay, the elements in gray box, okay, this indicated box, are metals. Okay, and the elements in the orange color block, okay, are non-metals, and the elements in the blue color box are metalloid. So we will discuss about metals, non-metals and metalloid in this chapter. Okay, so here let us see. Okay, iron, we have iron, aluminium, gold, copper, lithium, nickel, okay, titanium. So these are some of the examples of metals. Okay, iron, aluminium, gold, copper, lithium, nickel, titanium. These are some of the examples of metals. Let us see some examples of non-metals. Non-metals include phosphorus, oxygen. So the air that we breathe in, oxygen is a non-metal. Okay, sulfur, chlorine gas, carbon, iodine, bromine. Okay, all these are examples of non-metals. Okay, so now we have seen some examples of metals and non-metals. How do we classify them? Okay, so we will classify them based on their properties, different properties. So first let us see, here we have a copper bowl, we have iron gate, we have aluminium utensil, we have titanium, we have titanium, we have chromium. Okay, so these are some of the examples of metals. So let us see, okay, the physical properties of metals and non-metals. Now by understanding their physical properties, we will be able to classify the elements into metals and non-metals. So this given here are some of the examples of metals. Okay, so let us see the different physical properties, or the difference in physical properties of metals and non-metals. So here we see that these are the examples of metals. Now we see that most of the metals are solids, okay, at room temperature. Most of the metals are solid at room temperature. Okay, so that is the first property of metals. Okay, most metal are solid at room temperature, but there is an exception. Okay, exception that some metals are liquid at room temperature, including mercury, gallium, and cesium. Okay, so there is an exception. Most of the metals are solid at room temperature, but there are exceptions that mercury is liquid. Okay, mercury is the only metal which is liquid at room temperature. Then we have gallium and cesium. They have very low melting point. Okay, they have very low melting point. What about non-metals? So non-metals examples include sulfur, bromine, and oxygen. So here we see that sulfur is solid, bromine is liquid, oxygen is gas at room temperature. So non-metals occur in solid, liquid, and gaseous state. Okay, unlike metals, non-metals occur in solid, liquid, and gaseous state. So this leads us to the first point. Okay, the first difference between the physical properties of metals and non-metals, that is, most of the metals are solid at room temperature except mercury, gallium, and cesium, whereas non-metals occur in solid, liquid, and gaseous state. Okay, let us proceed. Here we see a person trying to break this. Okay, but instead, okay, it hurts his hand, so it is difficult to break. Another example we see here is a man, okay, he is trying to mold the iron, okay, into different shapes. So he first hit it and he hammer it. Yes, but it is difficult to change the shape of the iron. Yes, students, so what do we get from here? From here we can see that generally metals are hard. Okay, generally metals are hard and they have high density. Okay, but there is an exception. Some metals are soft. Okay, so examples are sodium. We see that sodium can be cut with a knife. Then lithium and potassium. So these are the exception to metals. Sodium, lithium and potassium are also metals, but they are soft metals. Okay, so sodium, lithium and potassium are soft metals. They have low density and low melting point. Okay, now let us see here. Now we see a girl writing or drawing using a pencil, but it broke, right? Another example we see is take a piece of charcoal and hammer it. What happens? It will break into smaller particles, correct? So here the pencil nib, okay, is made of graphite, which is a non-metal. Charcoal is a compound of carbon. So carbon is also non-metal. So from here we can see that non-metals are brittle. Okay, non-metals are brittle. They break easily. Okay, so here we have pencil nib, we have diamond, we have charcoal. Okay, so recall students, graphite, diamond and charcoal are different form of carbon. Okay, graphite, diamond and charcoal are different form of carbon. So we have seen that non-metals are brittle. Okay, they can break easily, but there is an exception. If you can remember diamond, yes, diamond is the hardest non-metal. Okay, diamond is the hardest substance and it is non-metal. Okay, so this leads us to the second point of the physical properties of metals and non-metals. That is, generally metals are hard except sodium, lithium and potassium, which are soft metals, whereas non-metals are brittle except diamond, which is the hardest substance. So this is the second point. Okay, the second point of the physical properties of metals and non-metals. Alright students, we have the first question for today. Please get your rough devices ready. The question is, an element X is soft and can be cut with a knife. This element is very reactive and cannot be kept in open air. Cannot be kept in open air or cannot be kept open in the air. It reacts vigorously with water. Identify the element. Okay, so I'm giving you 25 seconds for this question. Your time starts now. An element X is soft and can be cut with a knife. This element is very reactive and cannot be kept open in the air. It reacts vigorously with water. Identify the element. Option A is magnesium, option B is phosphorus, option C is calcium, and option D is sodium. Alright students, your time is up, and yes, very good. The correct answer is option D, that is sodium. Okay, sodium is a soft metal. It can be cut with a knife and it reacts vigorously with water. That's why it cannot be kept in open air. Okay, let us proceed. Let us see the next point. Okay, the next point of physical property. Here we see an ice cream man ringing bells calling for customers. Yes. Another example here we see is a boy riding a bicycle. He has a bell on the bicycle which he can ring. Yes. And here we see a person, okay, in a school ringing the bell when the classes are over. Okay, after every period or after the classes are over, the peon rings the bell in the school, right? And here we see a baby playing with steel spoon and steel plate. Okay, so when the baby hits the plate with a spoon, it will produce a ringing sound. Yes, so what do we see here in common? In all these examples we see that they are using metals. Okay, now when they ring the bell, it produces ringing sound. Yes students. Another example we see here is a mother gifted a pail to her daughter. Now when she moves her leg, it will produce ringing sound. Yes, so the substance that produces a ringing sound when struck are called sonorous. Okay, so all these substance, okay, when they are struck, they produce ringing sound, right? So these substances are sonorous. No? Now when we look at these examples, we see that all these are made up of metals. So hard metals are sonorous. Okay, remember sonorous means the substance will produce ringing sound when they are struck. So hard metals are sonorous. Now what about this one? When the boy plays with the ball, it does not produce ringing sound. Yes, but it produces dull sound. Now here we see a man playing a tabla. It will not produce ringing sound. Yes, it does not produce ringing sound. So non-metals are non-sonorous. Okay, non-metals are non-sonorous, meaning they do not produce ringing sound when they are struck. So this leads us to the third point, that is hard metals are sonorous, meaning they produce ringing sound when struck, whereas non-metals are non-sonorous. They do not produce ringing sound. Let us see the next point. Here we see a lady using gold ornaments. Yes, it is shiny in nature. Yes, students, do you agree? And here we see a new bell. We see that it has also shiny surface. Now let us see. Here a boy, okay, took an iron nail and sandpaper and polish it. Now we see that the iron surface of the iron nail is shining. Yes, students. So here in all these examples, again we see that metals are shiny, right? They have shiny surface. So metals in the pure state have a shining surface. Okay, and this property is called lustrous. So metal are lustrous. If it has a shining surface, then it will be called as lustrous. Okay, so metals are lustrous. Now what about non-metals? Let us take a charcoal, okay, and rub it against sandpaper. Will it become shiny? We see that small particles are coming off from the charcoal, but it is not shiny. Yes, it is not shiny. So non-metals are non-lustrous or dull. Okay, non-metals are non-lustrous or dull. Non-metals do not have a shining surface. Okay, but there is an exception to this, that graphite and iodine, these are non-metals, but they have shining surface. Okay, so iodine and graphite are shiny. So activity, okay, we have an activity. This will be your homework. Okay, rub the surface of the following materials with a sandpaper and make a note of the results. Do they shine? Okay, so take this substance like copper, aluminum, charcoal, rub it on sandpaper and check if they are shiny or not. So if it is shiny, that means it is lustrous. If it is not shiny, that means it is non-lustrous. Okay, so this leads us to the fourth point, that is metals are lustrous, meaning they have shining surface in the pure state, whereas non-metals are non-lustrous except iodine and graphite, which have shiny surface. Alright students, we have another question. Please get your rough devices ready. The question is, which property of metals is used for making bells and strings of musical instruments like sitar and violin? I'm giving you 25 seconds for this question. Your time starts now. Which property of metals is used for making bells and strings of musical instruments like sitar and violin? Option A is ductility, option B is sonority, option C is malleability, and option D is conductivity. So which of the following property of metals is used for making bells and strings of musical instruments? Alright students, your time is up. Now if you can recall metals that produce ringing sound, okay, when struck, are sonorous. Now we make bells and strings of musical instruments because they have ringing sound, correct? So the property of metals which is used for making bells and strings of musical instruments like sitar and violin is sonority, that is option B. Yes, so option B, sonority, is the correct answer. Very good students. Now let us see here. Here we see a lady covering food on the plate using aluminum foil. Yes. So here the boy is asking, Mom, what are you using to bake the rotis? Then the mother replied, it is aluminum foil. Now the boy is wondering, how can the same aluminum be used to make a thick container and a thin foil? So we have seen that aluminum is used for making utensils, correct? Utensils like this. But the same aluminum is also used for making a thin sheet like this, like an aluminum foil. So the boy is wondering here. Okay, let us see. We have a tin bottle cap. What happens to tin bottle cap when we hammer it? When we hammer the tin bottle cap, we can beat them into thin sheets, right? Let us see more examples. Take aluminum wire and hammer it. What happens to the aluminum wire? We see that aluminum wire is beaten into thin sheets. Yes. And here we see a silver foil on sweets as for decorative purposes. These shiny surfaces on these sweets are silver foil. Okay. So silver foil is used to decorate sweets. Another example we have here is in a temple, okay, a thin layer of gold, okay, is put on the entrance for decorative purposes. So here the little girl is admiring the beauty of this gold. Yes. So in all these examples we see that metals can be beaten into thin sheets, right? Like aluminum foil. Yes, like silver foil, like gold foil. Yes. So some metals are malleable. This property is called malleable. Okay. And what is malleable? The property of metals, okay, by which it can be beaten into thin sheets is called malleability. Okay, so some metals are malleable, meaning they can be beaten into thin sheets. Okay. Examples of malleable metals include aluminum foil, chromium sheet, copper sheet, silver sheet, gold sheet, zinc sheet, okay, and iron sheet. So these are some of the examples of malleable metals. We see that many metals can be beaten into thin sheets as shown here. Okay, so this property is known as malleability. Okay, know this. Okay, gold and silver are the most malleable metals. So here we can see that gold can be beaten without specific difficulty to thickness of 0.1 micron. So here we see that gold can be beaten into very thin sheet, okay, of thickness of 0.1 micron without any difficulty. Okay, so metals are malleable. What about non-metals? Let's take charcoal and hammer it. What happens? We see that the charcoal will break into smaller particles, but it cannot be beaten into thin sheets. Yes. So here, non-metals cannot be beaten into thin sheets, so non-metals are non-malleable. Okay. Another activity for you students, you can try this at home. Use a hammer and beat the following substance hard and find out what happens. Okay. First is copper wire. Beat the copper wire and see what happens. Beat the iron washer and see what happens. Beat the graphite or the pencil lead and see what happens. Okay, and see which of the following elements you can beat into thin sheets and which one you will not be able to beat into thin sheets. And this is how you can identify which one is metals and which one is non-metal. Okay, so precaution, take care that you don't hurt yourself while carrying out this activity. So this is the fifth point, okay, of physical properties of metals and non-metals. So some metals are malleable, meaning they can be beaten into thin sheets, whereas non-metals are non-malleable, they cannot be beaten into thin sheets. Another point we see here we see a father and a son walking by the road. Okay, then looking at the wires on the roadside, the boy curiously asks his father, that what are the wires made of? Okay, then the father replied, they are made of copper. Okay, they are made of copper. Then the boy now is wondering, copper ball is also made of copper. Copper wire is also made of copper. So how is that possible? Okay. So this property is known as ductility. Okay. So some metals are ductile. Let us see examples of ductile metals. Okay. Ductile meaning the metals can be drawn into thin wire. Okay. Ductile means the metals can be drawn into thin wire. So let us see some of the examples of ductile metals. So here the boy is visiting a shop and he is asking for the electric wire from the shopkeeper. So he asks, can you give me electric wire? Okay. Then the shopkeeper hand over copper wire to him. So we have copper wire, we have aluminum wire, we have chromium wire, we have silver wire, we have zinc wire, we have tin wire. Okay, so those are some of the examples of ductile metals. Okay, again know this. Okay, we see that gold can also be drawn into thin wires, and that is how we make necklace, okay, out of gold wire. So gold is the most ductile metal. A wire about 2 kilometer length can be drawn from 1 gram of gold. Okay, so remember this, students. Ductile meaning the metals can be drawn into thin wire. Okay, we have seen different examples of some of the examples of ductile metals. Gold is also one of them, and gold is the most ductile metal. Okay, let us imagine, take 1 gram. Okay, take 1 gram of gold, just 1 gram, not even kilogram. Take 1 gram of gold. This 1 gram of gold can be drawn into 2 kilometer length. Okay, so 2 kilometers is a very long distance, correct? So 1 gram of gold can be drawn into 2 kilometer length. So remember, imagine it. Okay, so here gold is the most ductile metal. It can be drawn into thin wire. Okay, so know this. Again, for non-metals, let us see what happens if we hammer it. Can we draw the charcoal into thin wire? No, right? The charcoal will break, but we cannot draw the metals. The non-metals cannot be drawn into thin wire. So non-metals are non-ductile. Okay. So here this leads us to the 6th point, that is metals. Some metals are ductile, meaning they can be drawn into thin wire, whereas non-metals are non-ductile. They cannot be drawn into thin wire. Alright, students, we have another question. Please get your rough devices ready. The question is, the property by which metals can be beaten into thin sheets is called which of the following? Okay, I'm giving you 10 seconds for this question. Your time starts now. The property by which metals can be beaten into thin sheets is called option A, ductility, option B, sonority, option C, malleability, and option D is conductivity. Alright, students, your time is up. And yes, very good. The correct answer is option C, that is malleability. Okay, ductility is for thin wire, malleability is for thin sheets, sonority is ringing sound. So the correct answer here is option C, that is malleability. Very good, students. Now let us see more. Here we see a lady cooking, okay, cooking curry in the kitchen. Now after cooking, we see that she is using some cloth to lift up the utensil. Yes, why do we do that? After cooking, we use cloth, right, to carry the cooking pot. Why do we do that? Let us see. Okay, so take this stand. Okay, take this stand. We have a stand, we have burner. Okay, we have a stand, we have burner. Fix a copper wire. Okay, so this is the copper wire, and put some wax on this copper wire like this. Okay, now heat at the end of the copper wire using the burner. Okay, heat at the end of the copper wire using burner. Now we see that it is becoming red. and after some time the wax begins to melt. Yes, it is because when this part of copper wire is heated, the heat is being transferred here. So this whole copper wire is being heated up, and that is why the wax melted. Okay. So metals are good conductors of heat. Okay, metals are good conductors of heat, and they have high melting point. Even when we use aluminum utensil to cook, the utensil does not melt, right? But it conducts heat, and that is why we are able to cook food. So metals are good conductors of heat, and they have high melting point. Know this. Okay. Copper, silver. The best conductors of heat are silver and copper. Okay, the best conductors of heat are silver and copper, whereas lead and mercury are the least or are poor conductors of heat comparatively. Okay, lead and mercury are comparatively poor conductors of heat. Alright, students, again we see here, okay, a mother cooking using this utensil. Now you see that these utensils are made of metals because they are good conductors of heat. But again, the handle is made of rubber, right? And it is non-metal. Okay, so take another stand here. Take the stand, burner, and take wooden stick now instead of copper wire. And put the wax like this. Now heat at the end of the wooden stick and check what happens. Will the wax melt? No, right? Even after heating for some time, the wax will not melt. It is factors of heat. Okay, exception, there is diamond and graphite, which are non-metals, but they are conductors of heat. Okay, so diamond and graphite are conductors of heat. Repeat the experiment with aluminum rod and iron rod. So we have done an experiment using copper wire and wooden stick. Now replace that copper wire and wooden stick with aluminum rod and iron rod and check whether they conduct heat or not. Okay. So this leads us to the 7 points, that is, metals are good conductors of heat, whereas non-metals are bad conductors of heat, with the exception that diamond and graphite are good conductors of heat. Let us see here. Here we see a man trying to fix bulb, okay, but he cannot reach it. So he asks his son to go and get him a stool so that he can reach the socket. So the boy went out and brought, okay, this stool for his father. The father stood on the stool and tried to fix the bulb, but we see that he is getting electric shock. So this is metal stool. So when the father stood on the metal stool tried to fix the light bulb, we see that he is getting electric shock. Okay, so here let us see. We have battery, we have bulb, we have copper wire. What happens when we connect this copper wire? The bulb is glowing, meaning the copper wire is conducting electricity. So copper wire is a good conductor of electricity. So here we see that metals are good conductors of electricity. What about non-metals? Let us see. The father asks his boy to go and get him a wooden or plastic stool. So the boy went out to get the stool. Okay. Now he brought wooden steel. So wood is a non-metal. So when he tried to fix the bulb, we see that the father was able to fix the bulb without getting electric shock when he used wooden stool. Now we have here this setup again: battery, bulb, and copper wire. When we connect this copper wire, the bulb begins to glow, meaning it conducts electricity. Now what happens when we use charcoal to connect these two wires? We see that the bulb does not glow because charcoal does not conduct electricity. So charcoal is a bad conductor of electricity. So from here we can see that non-metals are bad conductors of electricity. But there is an exception again. Graphite is a non-metal which conducts electricity. Okay, so think over. Okay, think over. We have this wire. Why plastic coating is used around electrical wires? These are copper wire inside, but the outer, okay, the outer layer or the coating of this copper wire is coated with plastic, right? It's made up of plastic. So why plastic coating is used around electrical wires? We know that copper wire is a good conductor of electricity. So when we touch it with our bare hand directly, we will get electric shock. Yes, but plastic is a non-metal. It does not conduct electricity. It is a bad conductor of electricity. So even when we come in contact with this plastic, we will not get electric shock. Okay, so to prevent from getting electric shock, the wires, electrical wires, are coated with plastic. Okay, we have an activity. Repeat the experiment with the following materials and record your observation. So we have done an experiment using battery, bulb, and different materials like copper wire, charcoal, right? So you perform this experiment by using aluminum nail instead of charcoal, use wood instead of charcoal, and use plastic instead of charcoal, and see whether the bulb glows or not. If the bulb glows, it means it conducts electricity. If it does not glow, meaning it does not conduct electricity. Okay, so this leads us to the 8th point, that is, metals are good conductors of electricity, whereas non-metals are bad conductors of electricity, except graphite, which is a non-metal but conducts electricity. Okay. Alright, students, so let us recall the different properties, okay, of metals and non-metals, the different physical properties of metals and non-metals. So we have thermal conductivity. We have seen that metals are good conductor of heat. Now when it conducts heat, it is known as thermal conductivity. Okay, we have seen that metals are good conductor of heat, whereas non-metals are bad conductor of heat. The next we have is electrical conductivity. We have seen that metals are good conductor of electricity, whereas non-metals are bad conductor of electricity, with the exception that graphite is a non-metal which conducts electricity. The next we have is ductility. So what is the meaning of ductility? We have seen that ductility means the property by which the metals can be drawn into thin wires. So metals are ductile, whereas non-metals are non-ductile. The next we have here is a thin aluminum foil. Yes, so this property is known as malleability. Okay, the property by which metals can be drawn or can be beaten into thin sheets is called malleability. So we have seen that metals are malleable, whereas non-metals are non-malleable. The next we have is lustrous and sonorous. Lustrous is the property of metal having shiny surface, correct? So some metals are lustrous, whereas non-metals are non-lustrous, with the exception that graphite and iodine are non-metals which have shiny surface. Okay, so some metals are lustrous, whereas non-metals are non-lustrous. What is sonorous? Sonorous meaning it produces ringing sound when struck. Yes, so some metals are sonorous, whereas non-metals are non-sonorous. Okay. Then the next we have is the strength. Yes, metals are hard and they have high density, whereas non-metals are brittle. Okay, whereas non-metals are brittle. We have seen the exception that some metals are also soft, like sodium, lithium, potassium. Okay, and some non-metals are hard, like diamond. So some metals or most metals are hard and they have high density, whereas non-metals are brittle. So these are the different physical properties of metals and non-metals, and based on these physical properties we can classify the elements into metals and non-metals. Okay. Alright students, so this leads us to the last question for today. Okay, oh, not the last question, one more question. The question is, generally non-metals are not lustrous. Which of the given non-metal is lustrous? I'm giving you 10 seconds for this question. Your time starts now. Generally non-metals are not lustrous. Which of the given non-metal is lustrous? Alright students, yes, very good. Here the correct answer is iodine. Iodine is non-metal but it is lustrous. It has shiny surface. So the correct answer is option B. Very good students. So students, this leads us to the last question for today. Please get your rough devices ready and respond to this question. The question is, how do you feel about today's class? Okay, I'm giving you 25 seconds for this question. Your time starts now. How do you feel about today's class? Option A is happy, option B is quite good, option C is satisfactory, and option D is confused. Yes, students, please give your feedback about today's class. Alright, students, your time is up. Thank you so much for your response and thank you for joining today's class. I will see you again in our next class. Till then, take care everyone and have a nice day.